this computer. Okay, started recording a little bit late, but for those of you who are not watching, we're just talking about strings, and I've been talking about Unicode strings, about the fact that a string is just a sequence of Unicode symbols. It's not a sequence of bytes. So if you're familiar with ASCII and byte strings, understand that Python doesn't have, byte strings are a different kind of thing. They're a sequence. Python strings are all Unicode strings. They're all a sequence of symbols where each symbol is a Unicode character. When you're doing text processing, that's just fine. Where the complication gets in is if you're used to various tools and you're used to knowing that each character represented 1 byte in memory. You can have that functionality in Python, but they're just not normal strings. Okay, so a string, as I said, is a sequence of characters. Okay, and one of the things about characters is we can go and we can pick out each individual symbol. So if I've got a list of characters, the very first symbol is the 0 symbol. The very first character in this string is 0. If I want the 4th character, I would actually do 3. Now, counting is a little bit odd. Python, being in the heritage of the C language, counts 0, 1, 2, 3, 4. So when we're counting, this is the 1st spot, 2nd spot, 3rd spot, 4th spot. We call it the 0 location, the 1 location, the 2 location, the 3 location. So addressing is 0 index. So 0, 1, 2, 3. It's just the convention. There's a lot of reasons in computers why counting at 0 makes sense. One of the things you can also do is count from the back, from the end. So if this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I could talk about the 12th character. So that's the 12th character. Notice that even though you see 2 symbols, that's 1 unique Unicode character. I can also count from the back. And I could say, you know what, go from the end and give me the last character. Or give me the 6th last character. And what would that be? Well, character 1, character 2, character 3, character 4, character 5, character 6. So minus signs, you can count backwards. Strings are even more powerful than that. You could talk about individual strings. You could also talk about string ranges. So when we talk about string ranges, if I only want part of the string, what I can do is I can take this string and say I want all the values up to the 5th character. So if we do that, right, MIST, this is 0, 1, 2, 3, 4. And the way that we do counting in Python is up to but not including. So you could think of 5 as being representative of 0, 1, 2, 3, 4, 5. This is the 5 position. It's actually the 6th character. When we say up to but not including, all ranges in Python work this way. It's everything up to but not including that value. If you want to do a more limited range and you want to say say 6 to 8, this is saying start at character number 6 and go up to but not including number 8. And so you can see in this string, 0, 1, 2, 3, 4, 5, 6, start at 6, then 7, but go up to but don't include 8. Sometimes it's helpful to think about these numbers as not being the characters themselves, but being the space between the characters. And so rather than thinking about this being the 0 character, think about my cursor being right here. That's the 0 position. This is the 1 position. This is the 2 position, 3, 4, 5, 6, 7, 8. So that spot right in the middle there between the N and the G, that's the 8th position. And so when we say from 6 to 8, it's saying from position 6 to position 8. If you think about these numbers as being the locations between the characters. Anyways, you can do indexing. You can do lots of things with strings. Strings are a native data type within it. So if I have two strings, like the string hello and the string world, I actually can add those 2 strings together. And so you can create a new string. Variables just represent strings. So I can say the word say and add it to this variable. And that will take the word say and the word hello world and add them together. So I get say hello world, okay? So you have the ability to add strings together. Some operations like plus work, other operations do not work. It doesn't It does not make any sense to say yellow minus red. It'll say, yeah, I have no idea. An unknown operand type says, what do you mean to minus two strings together? I don't know what that means. I know what adding means. It means to concatenate them together, to add them together. But not all arguments work. There is a function that's used for all sorts of sequences called len. It's short for length. If I want to know how long a word is, it's 13 characters long. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 13. And again, you're going to index this from 0 to 12. There is a contains function called in. If I want to know whether or not a substring exists inside of a word, I can say there's hello or inside there. But if I take another phrase, goodbye in B, that's false because the string goodbye is not in that string. I talked about data types, how minus sign is not known and times plus is known. Well, another thing is if I want to say hi plus hi plus hi plus hi, right? I can do that. But we know from mathematics that really that's just the same thing as saying hi times 4. And so this is sort of cool. If you actually want to have a bunch of characters, you can multiply a string times a number. Now you can't multiply a string times a string, but a string times a number works. So if you ever wanted to do something like have, I don't know, 6 tab characters, and then say your title of your thesis, that's allowed. And you'd have 1 tab character, 2 tab characters, 3 tab characters, 4 tab characters, 5 tab characters. I often use this when I'm debugging, where I want to have like a bunch of stars, 10 times star, right? Where you want to have a bunch of symbols and then some text and a bunch of symbols. Well, 6 is the number. Times is a asterisk, meaning representing multiplication, and then star is just a character star. So there is a row of 6 stars and this. It's a nice way of making beautiful titles in your code. When you're doing string manipulation, there's a number of methods you might care about. One is a strip. What strip does is it takes a string and gets rid of all of the leading and trailing white space. Now, white space refers to tabs, spaces, new lines, and carriage returns. So if you ever had a string that has stuff at the beginning and stuff at the end, and you want to get rid of it, that's what strip will do. There's functions for converting to lowercase and uppercase. If your string has, right, so that was my string. Obviously for 1, 2, 3, 4, there is no lowercase, it just leaves it by itself. All lowercases turn into uppercases, right? So there's those functions. And finally, there's a replacement, which is basically just a search and replace. You could think about a replacement as doing something which finds where something is in a word, identifies its location, and then taking those spots builds a new string where it replaces these characters with these characters. And so that's implemented. And there's a number of other string methods, and these things are usually learned by practice. Typically, if there's some operation that you want to do, rather than having to write a piece of code that does it, take a look at the documentation in Python, take a look at the documentation for strings. There probably is something that does it. So here is just a snapshot of some of the operations. There's a find, there's an index, there's a, is this a letter, is this a number, replacements, search it from the right-hand side, split it into a number of pieces. I use this one all the time in my own coding. So you might have something like a path, right? So you might have something like mount C, users, Jamin row, downloads, myfile.txt, right? So you might have a string like that, and you're like, well, I need the pieces of it. Well, it's a string, so you can split that by a symbol, some delimiter. And so now that splits it up into the first thing, the second thing, the third thing, the fourth thing. So split can be very useful for splitting things up. Strings have a quality. and they're like arrays. They're acting a lot like arrays in the sense that I can have a string, and I can talk about a certain subset of those characters. Say just 4 to 6, just those 2 characters right there. But what I can't do is update them. So what I can't do is have a string like hello world. Oops, that's not in there. And I can't go and take the second character and replace it. That's not allowed. So one of the things that strings cannot do is what's called item assignment. And that's because strings are immutable. So that's a technical term. It basically means read only. When you create a string, you never change it. Now, to be clear, I am allowed to do this. Okay, I am allowed to change the value of s, but I'm not changing the underlying string hello world. I'm actually creating a brand new string called goodbye world and assigning it to s. I can take s and add it to something. Okay, that's not changing s. What that's doing is taking the old value of s and creating a new string with a exclamation mark. That's a new mapping of memory. And so this has to do with how memory is used within Python, but strings are not mutable. So once you have a string, it's a unique piece of text that lives in memory and it never can be edited. You can make copies of it, you can make new strings, but you never modify the string in memory. And so what that means is all operations that manipulate string data, they're always creating new strings. So every one of these functions is not modifying the memory that the string represents. It's actually taking the contents, doing something, and putting it somewhere else in memory all the way through. There are some helper functions that allow you to convert from values to strings, right? And we talked about this before, where if I have a number, whether or not it be a float or an integer, the str will convert that thing into its string representation. So I can say, well, what's the string representation of 12.3? And it will do that. And again, what it's doing is it's converting it into a string representation. It'll do this for any sort of data type. So the string representation of the word true is actually true. So this is the best representation as a string of something. And anything can be turned into a string. So if you just type in some command, print, okay, it says print is a built-in function. The string representation built-in function, okay? That string is what print is being represented as when it's a string. So string itself is a function, and that's just a class. And so the string representation of the class string is the string, class string, which it's just what it does. It's putting it into a representation as a string, which best matches what these things are. Now, as I said, there are a different kind of string. There are these things called 8-bit byte strings, which you might need sometimes, especially if you're doing low-level input-output. Those strings are done by putting a B in front of it. And when you do that, if you have some data that is a B, now it feels like it acts like a normal string, okay? Except for now each character, that's how long it is. There are 13 characters, and if I say -1, okay, this is still. Oh, okay, that's interesting. Yeah. Okay, so what we're seeing here in a byte string, remember I talked about the relationship between characters and their numerical representation? So you can see how this string data, each character is actually mapped to a number. So number 10, that is the ASCII code for an N. The ASCII code for an L is a 1. The ASCII code for a capital H is a 72. Okay, so a byte string is basically saying here is a sequence of bytes. And I can play with these things like you would in binary data. Notice that there's always going to be a B in front of it if it happens to be a byte string. They're just completely different things, If you're going to work with byte strings, that means you're going to be dealing with byte strings all the way through. Life gets a little bit confusing if you need to convert from a byte string to a text string and back and forth. What you actually need to do is encode it. And that has to do with how numbers are represented, or letters are represented. You need a certain way of encoding from numbers to text and text to numbers. Just remember these two. This is how you go from a byte string to a text string, or from a text string to a byte string. And they're just two different data types. There's something called raw strings. I'll let you read about that on your own. It just gets rid of these slashes. Here is a cool feature. We talked about normal strings, talked about byte strings. Here's something called an F string. And I gave you a little hint of this last time. This is a feature that's in Python 3.6 or newer, so that's what you should be using. What it allows you to do is construct a string which actually pull in variables in one go. So what I can do is I can have some variables like IBM 191.1 as a share, or a stock, a share, and a price. And every time I see a curly bracket, that value gets evaluated. The name of the expression goes before the colon, and everything after the colon is called a one, two, three, four, five, six, seven, eight, nine, 10, and represent this thing as a decimal number, as in a base 10 number. Then give me the price, put that in a field which is 10 characters long, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, represent that as a floating point number, which you use 2 decimal places. In fact, this notation can work with not just variables, but any Python expression. So here is a Python expression that I have name equals IBM, and I had shares equals 100, shares equals 100, and price 1, and I was to try a line like this, okay? What we're doing is we're taking anything inside the curly brackets, and any expression goes before the colon, and how do we want it formatted. So shares times price is going to be something. It's going to be 100 times 91.1, so $9,110. Formatted in a string at least 0 characters long. So strings will be longer if they need to be. This won't crop them, but put 2 decimal places. And so you can see B now is the string for $91110.00. So it's a way of formatting things all the way through. Okay, let's play around with these things. So I want you to be doing this interactively with me. So hopefully you've got a Python terminal. Let's just play around with these things. Open up a Python terminal and do these things with me. So the first step here is to define a list of stocks. Okay, so let's do that. Symbols equals AAPL, IBM, Microsoft, Yahoo. I don't know what SCO is. It's another technology company. Okay, so we got that. You can copy and paste that if you choose. Okay, so let's just play around with these things. So really quickly, you give a shot at typing out these lines, but just before you hit enter, take a look at your string and see if you can figure out what they're going to get, right? So symbols of 0. Okay, what's that? It's the first character. I'm expecting to see an A. I get an A. Okay, symbols 1. Well, that's the second character. I should see another A. Okay, that makes sense. Symbols, let's be something a little bit fancier. 5. 0, 1, 2, 3, 4, 5. That should be a comma. Okay, so just do this yourself for a moment. Make sure this all works as expected. Try the negative sign, right? -2. What are you going to get when I hit return? Well, you should take a look at your actual underlying data. So 1, 2. Think about what the answer is going to be and go, did I get it right? And if you got it right, great. And if not, ask a question. I'm seeing a question in Slack. I'll wait for that if you want. Remember, you can't update strings, so you could try this yourself just to see if you get the error message. Okay, what if I take the first character in symbols and I try and change it, that's the warning because I can't do it. Okay, let's play around with string concatenation. Let's say that I had a new stock I wanted to track. So I'm going to try symbols equals symbols plus Google. Okay, again, I'm not modifying it. I'm adding characters to it and making a new string. And you can see now symbols now has this new set of information. Oh, well, that's not what I really wanted. I really wanted a comma in there. Okay, so now here's your challenge. Okay, what should I do to get this comma in there? So I want to fix it somehow. How could I fix it so that this thing became had a comma right there? So try something. And while you're trying something, I will give you a couple different options. Okay, one option would be that. Yep, a replace would be good. And I never know which one that's going to be. There's another variation on a theme where I take the string, I took the first 23 characters, then I added a comma, then I added the next one. So either one, that or replace, either one of those things would work. Okay, how would I go about adding HPQ to the beginning of it? So try something. And hopefully, so that symbols now says this sequence of characters. Okay, so the point here is, even though we're always using the word or the variable name symbols, we're not actually changing it. We are constantly creating and then destroying these old strings and creating new strings all the way through. I talked about membership testing, that you can go through and see whether or not a substring is in it. So let's just play with that to make sure it works corrected. Okay, is IBM in this string? Is it a substring? And so just look at it, try and answer it for yourself, going, should I get what am I going to get as an answer? Okay, AA is in symbols. That makes sense because there's AA. So here's the letters KAT. Is KAT inside this string? And so hopefully, if you're doing this along, you should go, well, that's fine. And again, I would just encourage you to play along with this and be like, okay, just try it. Confirm that it works as you expect for symbols.lower, and then do some finds, and then do some F strings. So I'm going to leave this as something for you to work on, just to play with it. The idea is to try it out. I don't need to see that you've done it, but what I want you to do is I want you to add that functionality in there. And specifically, here is something that I do want to see. Mortgage.py is a program that we had worked on the previous day. And remember how I said, as you're going through these files, what you're going to do is you're going to always be modifying and editing these programs. So here's the mortgage program. Okay, and this is what it does. Modify it so that its format is nicely aligned, right? Okay, so that's sort of cool. I guess we have to, I didn't finish my assignment. I wanted a table, right? Remember there was a table of payments every month. You could modify this so that it all looks pretty good. I guess I should go back to exercise 1.10 and finish it. You should finish it. But these are the instructions, and I want you to sort of do this on your own. Okay, so there is something within strings that we should talk about, and that's called regular expressions. So regular expressions is a more advanced way of doing matching. So far, what we have is the simplest kind of expression, where if I have a string, okay, I can say, is this string inside this string? And that's a form of pattern matching. It's looking for this string inside of here. It can be any substring. So if I look for the characters WOR, it's looking for those characters inside of here. And it can be any sequence of characters, right? I could take the O from world, and that's going to be in it. But the order matters, right? So if I just flip that around, that sequence of characters as written is not in the string hello world. Okay, if I want to do anything more complex than straight up mapping, I need to use what's called a regular expression. Now, regular expression is a whole topic in of itself, but it's a way of doing matching, okay? So here is a piece of text, okay? The text is a string, okay? So I'll just copy and paste, Python. Okay, so there is a nice string. What I want to do is I want to find in this string all of the dates. Okay, I want to find any substring which has the pattern, a number and a slash and a number and a slash and a number. Okay, there are ways of encoding this with what are called regular expressions. So there's a couple things about regular expressions. And we can do a lot more on this, and we might come back to it, but I'll say it briefly. That in a regular expression, characters match themselves. So if I want to do a regular expression for a T, an O, a D, a Y, a space, characters just match themselves. What you do is you use these escape codes to match whole classes of characters. So here we go. Let's import RE, which is the regular expression library. And inside regular expression, there is a function called findAll that takes some string and looks for it inside the text. So I'm going to look for the word is inside that text. And it's going to find all the examples of inside this string that match the letters I, S. Okay, well, that's pretty boring. But I can do more. What I can do is I can say, you know what? I want to match all of the numbers inside of the word text. So these are all of the digits. Matched is the 3, the 2, the 7, the 2, the 0, the 1, the 8, the 3, 2, 8, 2, 0, 1, 8. Okay, so what we're doing with this escape code is we are matching all of the digits. Now, remember that these backslashes, if I wanted to, now there is no character class I can think of an N, but just so that N's and D's and R's aren't special, I'm going to make these raw strings. And what R does is says, ignore any of the escape sequences in this string so that that never becomes a problem. So I want to ignore all my backslashes. Okay, next bit of regular expressions. Regular expressions can map sequences of things in the sense that if I want to map one or more numbers, what I can do is I can have the character /D, which represents any digit 0 through 9. If I put a plus through it, it says any sequence of digits 0, 1 or longer. So what this is going to do is map any sequence of digits, which is 1 or longer. So what are the sequence of digits? There's a 3, and then something which isn't a digit, then a 2, 7, and something that isn't a digit, and then a 2, 0, 1, 8. So if I match that pattern, you see what it's pulling out is the 3, the 27, the 28, the 3, the 28, and the 27. So this is where regular expressions start to get really powerful, is what we've done is we've extracted from the string all of the numbers, okay? And I can be a little more complicated. I could say, you know, I want dates. And so dates have the form of a number, then a slash, then a number, then a slash, right? So what I've done here is I've built up a regular expression which matches sequences of dates which are number slash number slash number. So that's the pattern. And you can see that now what it's looking for is the pattern number slash number slash number, number slash number slash number, and it's found 2 of them. Okay. Now this gets a little bit cool. Once I've identified that, regular expressions can actually hold on to what these pieces really are. And so I can use a regular expression to say, you know what I want you to do is find that regular expression, but I want you to hold on to what these things are. And I do that with round brackets, okay? And it says, when you pull this out, what I want you to do is still pull it out as a group, but identify what the first thing, the second thing, and the third thing is in each part. And so you can see we have more structure now. We have, and we'll talk about these in a second in terms of containers. These dates are made up of 3 parts: a day part and a year part, a month part, a day part, and a year part. By using brackets, round brackets, that says to regular expressions, I want you to track that unit as something, as a thing, right? All the way through. So I can identify the parts of it. Now, there's other things you can match within regular expressions. If characters are, if numbers are this thing, then all of the words, I'm pretty sure, oh, I need to make a string. Is it? Yeah. S is for spaces. So it's all of the spaces of the text. And W is letters. All of the textual stuff that's not words, right? And so there's a number of these codes that match certain things. So those are things that are not words, but they could be punctuation and not. Capital S is all things that are not spaces, right? So if S is a space, capital S is things that are not spaces. So there are these symbols that we can use to match things. Finally, what you can do is you can match things that are in a sequence, right? So I could say, you know what? I want to match anything that's inside the set. Maybe it's A. No, it's not a /A. I'm going to go with this one. I want to match anything that's in the range A to Z. Okay. So those are sequences, or any sequence which is a character. In fact, I want to measure any sequence of characters. So anything in the range A to Z, 1 or more of them. In fact, you know what? I want to match anything in the sequence A to capital Z or A to little z. So here is all the words inside this string. Okay. So what I'm doing here is I'm mapping a word, and that could be today is, tomorrow is, and then some text. And so I can get quite powerful with this thing. What I could do is I could say, you know what? I want you to map or look for any word, right? So this is going to match one single word separated by spaces. Then I want you to map the word is. And then what I want you to do is I want you to look at dates, okay? And I'm going to grab my little syntax here for dates. Okay. So what I've done here is I have mapped in pieces the word and then the date as month, day, year from the string. And what it's done is it's taken the string and found that there is a today, month, day, year, and a tomorrow, month, day, year, and grouped into 2 subparts. Regular expressions are amazing at taking a string which has some structure to it and breaking it up into parts. And as you learn more about the library, you can use that to do replacement. So let's say, for the purposes of this example, I have this string, or not string, text, and I'm going, you know what? It's in the wrong order. I don't want year, month, day. I want to do something different. Well, so here is a regular expression function called substitute. Substitute anything of that pattern, right, with this new pattern. And this new pattern is take the third item you matched, then a dash, then the first item then you matched, then a dash, then the second item you matched, and then a dash. So take first thing, second thing, third thing, and replace it with third thing, then a hyphen, first thing, then a hyphen, then the second thing. And do that on argument, on text. And so what we've done is we have translated this phrase into this phrase. And this ability to, in one line, do these kinds of really actually quite sensitive textual repositionings is what gives Python some of its power. A lot of scripting languages have this, Perl and other ones like it, but this is a really strong value about knowing regular expressions. You can do string manipulation all the way through. And you know what? Let's see the regular expression library for more details, and we'll keep on moving on. Indirectly, if you're trying to do discovery on these things, so here's some strength. What else can you do with them? Okay, if I just type in text and then a dot, and I hit the tab character, nothing interesting happens, okay, by default. And that's because in this particular editor, it's very, very boring. It's the most simple one. In some other environment variables, if you hit the tab key, okay, like as in you type in like the tab key on your keyboard, you'll get a rendering of all of the methods associated with this. I don't have that here, but I will tell you that there is a function called dir, standing for directory, that will tell me everything I can do with a piece of text. And so here is the list. Here are all of the functions that you can do with a piece of text. And some of them we've talked about. We've talked about a replace. We've talked about a lowercase. Here's one that's called swap case. So if I have a string and I swap case, that'll make all the lowercase uppercase and all the uppercase lowercase. Okay, so those functions are there. These other ones are the ones that are built into the function, and these ones with the double line on them, they're there as well, but they're just the way you call them is a little bit more interesting. This len thing, this is the function which gets called. So if I say text underscore underscore len underscore underscore round bracket, I get 42. This is the function that is called when I type in len of text. What len does is it takes text and then looks for a function called underscore underscore len underscore underscore and runs that. And in fact, equalities, less than or equal to, or less than or equal to, less than, modulo, different mathematical operations, those are built into this thing. Add. So you know how I said, remember how we talked about A plus B? That works, but A times B doesn't work? Okay, that's because what's going on here is the add function is being called when you do this thing. So if I wanted to, I can have a string, and then I can go add, and then another string. Okay, and you see what that is? That's equivalent to saying A plus B. When I do multiply, what that's doing is taking the string, calling the multiply function, and then putting an argument. Now, if I put in a string, it's this function which is saying, I don't know how to do that, but you could have 12 A's. So when you're looking at this dir command, it's all of the methods on a particular Python thing, and everything that's a double underscore, those are just implemented as operations or other functions. Anyways, it's a good way of doing discovery of what's going on. Okay, so that's numbers. Now, one of the things we noticed that when we used the find command, and I'll just go back and get a find command. Remember I did this discovery? These things right here, okay? These are containers in Python. And so in a similar way to strings, they're a way of having an ordered sequence of things that I can pull the components out. And the first one we're going to talk about is this idea of lists. Okay, now a list is a sequence of things. In some ways, a string is sort of like a list, but it's not quite. Okay, it has the idea of sequence and order. Okay, so let's do this. Here is a list, and lists are always indicated by square brackets. So this list. Okay, so I'll put it into a name. my list is equal to, and I'll just take this whole string, copy and paste it. Okay, so there is my list. Okay, my list is a sequence of things. There are in my list 2 items. Here is the first thing. Here is the second thing. Things are separated by columns, by commas. You see in these examples for names, the first thing is the string Elwood. The second string is the word Jake. The third is the word Curtis. Each one of those things are in the list. Lists can contain any combination of things. In fact, there's no need for my list to even contain even the same kinds of things. Okay, so this is a list of a string, a number, and then another list. So lists can contain lists, and this gives you the ability to do lots of interesting sort of data structures with it. And in fact, what we're looking at here is this is a list of 2 other things. These things are not lists. We'll talk about those in a second, but they're just things that you can do. If I had a piece of text, okay, so let's say if I had a bit of text like this line, which might represent a stock price, if I say line.split, we talked about split before, what it's doing is it's taking that string and giving me back a list. Why do I know it's a list? Because I can see these square brackets. Okay, so if I take that and put that into a variable, with a list, I can do something similar to what I do with a string, which I can talk about how long it is. I can talk about its first element, its second element. I can talk about its first and second elements. I can talk about its last element. Okay, and what I'm doing is I'm just picking these things out as the first, second, third thing in a list. The fundamental difference between a list and other data types is it is mutable, which means that if I have a list of things, so say I have a list of names, for example, I have the name Jake and Elwood and Curtis. Okay, so there's a list of names. If I say names.append and I add another name, Murphy, okay, notice how I don't get something back. When I write that in, I don't get anything printed on the screen, and that's because lists are mutable. They are changeable. And so the actual names has changed. And so what's happened is names used to be Jake, Elwood, and Curtis, and now it's Jake, Elwood, Curtis, and Murphy. In fact, you've got the ability to take something and insert them anywhere you like. So if I use names.insert, this will insert into this list at position number 2, the name Aretha. Okay? You don't see anything. Why don't you see anything coming back? Is because names itself has been changed. And exactly when I talked about positions, you can think about the 0, 1, 2, 3, 4 as not being the elements, but being the spots between the elements. So you can imagine this spot right being here being 0, this being 1, this being 2, 3, and 4. So position 2, 0, 1, 2, it's like right here. It's saying right in this spot, I want you to insert another thing. What do I want to insert? The string Aretha. So now Aretha has been inserted at position number 2. Strings understand a lot of things. So if I take names, okay, here are all the methods of them. And one of the methods of them is an add. Okay, and I said anything with the underscore, we don't call it self, but it means that it understands how to do this. So if I take a string, like list 1, 2, 3, and another list A, B, 2 lists of things, one of the things that you can do with a list is you can add them together. And when you add things together, you get a new list, which is the concatenation of them. So addition makes sense. Now, again, S times T, that isn't well defined. However, if you want to have 10 lists all added together, go ahead. So there is 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. You're just a sequence of 1, 2, 3s all added together. Okay? So there's a lot of crossover between how strings work and lists work. And this is actually part of the power of the Python mindset, is both strings and lists are examples of sequences. And so the way you look up a subcharacter, whether or not it be the square brackets, it's the same notation, it's the same syntax. You can do it. You can talk about the length of a string, you can talk about the length of a list, you can talk about the index, picking out an element, an item out of a list, you can pick out an item out of a string. But there are some things you can do with lists that you can't do with it. So if I take a string, like my string names, I can modify one of those names, and I can change it and replace it. And again, nothing gets spit out on the screen because what's going on is the underlying first value has been replaced with something else. Okay, so I can put anything I want in as a member of that list. I've already talked about length. Length, like any sequence, has list. There's the ability to say, is this item inside of a list? Is this item not inside of this list? So I can ask the question, is Elwood one of these people in my list of names? Is Brittany in this list of, names? No. Okay, I can ask this as a direct question. Is Brittany not in this list of names? True. We talked about replication. Okay, so there's the basis of lists. We have this ability to go back and forth. One of the things lists are used for extensively is to iterate through. You might be familiar with in some languages that if I had a bunch of names, right, and I knew how many long they are, I would have to do something like a notation for I in, and then some sequence. I'll say 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4, right? I could iterate through them, and in principle, I could do something like that, okay? This is how you would do it in other languages, right? You have to have some counter or some index, and the index goes all the way through. In Python, because sequences have the idea of order, you actually can bypass all of this I subscripty kind of stuff and just do this. How about I just say, give me a list of names, and every time I want a name, call that variable name. So now I can say, give me the first item out of that list, print name. I am now getting the sequence of names. And this value of not having to do this, but being able to go straight to the things, this is one of the features of Python. When people come from other programming languages, Java or C, and you see them doing this kind of stuff, they're trying to apply idioms or ways of coding from another language to Python. And we would say, that's not really Pythonic. That's not really the way you do it. This would be a more Pythonic way of doing that same solution, okay? In JavaScript, for each would be something like that. Okay, we know how to take a list. We know how to insert it. We also can remove it. And there's two ways of removing it. I can remove it based on a lookup. So I could go through here and search for the word Curtis and remove that. So if I say names, remove Curtis, that is one way of doing it, okay? And you can imagine that you have, right, that will go through, identify where that thing is, and then remove it. But what happens if you had multiple entries and you wanted to remove this one and not some other one? Well, it's a little bit odd, but what you do is you delete the object that's associated with that entry. So if I delete names 1, I am getting rid of or removing from memory the thing that was in that position all the way through. Removing doesn't create a hole. What it does is it just links it together. Lists can be sorted, okay? And because they're mutable, what you can do is you can have a list. So let's have a list of some numbers, 10, 1, 7, and 3. and I can sort that list. And again, nothing comes out because lists themselves are being manipulated. And the list is now sorted. I can take the list and I can sort it in a reverse way. Okay, and now the list is sorted in reverse. And again, for any of these functions, if you're like, well, what other things can it do? Remember that there is really good documentation built into the language. So if I say help s.sort, it gives you the documentation on how this thing works. So here's the documentation. Help, you put in any sort you want. This is actually the thing. You can reverse it. In fact, you can sort based on a certain key. A key function lets you change the nature of sorting, right? You want to sort on integers or capital letters or floating point numbers. You can modify that. So just remember that there is documentation for all these things. Now, sometimes you have a list, okay, that I'll just say reverse normally. Sometimes you have a list, okay, and you want to have the reverse list, but you want to keep the original list. How can you do that? Well, there is a way of calling not sort, but sorted, which takes a list, does something you want to do with it, and actually returns another list, but not modifying the original list. So sort takes a list, changes it in memory so that it's permanently changed. Sorted takes a list and creates a new list that relieves the original one. Okay, so lists have the idea of insertion, order, and sorting. One can start to do some very simple vector operations. They just don't work well, okay? No one does math like you would in MATLAB or R or Octave with Python in this way, okay? You might think that might be represented by an array. This is for sequences of things. It's not for vectors. There was another way of doing it, and that's called NumPy, and we'll talk about that. It's a really important scientific library that's used everywhere, but we don't do math with lists. They're very inefficient. Okay, so here are some exercises to work with on this idea of lists. Here is a string of things. We talked about strings. We've talked about the split operation that splits something up into a bunch of sequences. Okay, so you can just play with these for a moment or you're later at your leisure. Does it make sense that what this becomes is a list of the first, second substring, the third substring, the fourth, fifth, sixth, and seventh? And then you can extract out those pieces. You can replace things one by one, and you can look at subsequences all the way through, and you can do appends of them, and that's all allowed. Okay, so I'll leave that because I think that's pretty straightforward. Go ahead and go through it yourself if you need to. You can loop over things. So if I have a list of symbols, you can go ahead and you can just loop through them. And again, S takes on the value of each one. Membership tests, just like in strings, we can just replace, we're looking for a string element to see whether or not that element, that item, is inside the list. And we can do appends and we can do removals. Okay, so I think that's all fairly straightforward. Go ahead and take a look at it. We talked about sorting. Okay, this is sort of cool. If you have a bunch of, if you have a string, right? So if I have some text in a string, we've learned that what you can do is you can take that string and you can split it, split by commas. And so now symbols is a list. Again, how do I know it's a list? Square brackets. What if I want to take that list and put it back together as a sequence, as a string? Well, there is a special operator, and I'll just show you this right now. I'll take my text string. You remember how we did this? Okay. There is a function called join that is a function of any string. Okay. And again, if I do help of text.join, what it says is it joins anything that's iterable, anything that's a sequence, like a list. It concatenates them all together, where the string is inserted between each given string. And so what this means is the separator is actually the string you're calling join on. Okay, let me demonstrate this. So I've got a string, okay? Here is my string. It's a perfectly nice string. It's a string that contains a hyphen. That string, I can do operations to it, right? I can say, I can do something like a join. The way that join works is it takes anything that's iterable, anything that's got a sequence, and puts them together with this string in the middle. So if I take that list of symbols, it's taking the list of symbols, and for each one, putting a comma right in between. I can do this with any sequence all the way through. So if I took the sequence hello world, okay, this is a sequence, the first, the second, the third, the fourth, that I can rejoin together with dashes. In fact, I could just take any word I like, any phrase, right? So there is a symbol, and I could join that with a list of symbols. Whoa. Okay, so you see that I'm doing is that first thing, then this is the separator, and this thing, then this is the separator, and this thing, and this is the separator. You can see you can start to get some pretty verbose descriptions. You can do it with commas. And sometimes what you want to do is you just want to have the symbols, and you want to do the equivalent of saying text equals symbol 0 plus symbol 1 plus symbol 2, right? And yeah, that will join them together. And you could be fancier. You could use, you could have some loop that starts off in separate. And you could say for sim in symbol, what are you going to do? Text is equal to text plus symbol. Okay, and I can see the text. I've now got them all joined together. This works, but again, that's not very Pythonic, because Pythonic says I can take any string and join things together. And in fact, that is a perfectly valid string. That is the empty string. It's the nothing string. It has nothing inside of it, but it's a string, which means I can join any sequence of things together. And so I can just join these characters, Yahoo, RTH, HPQ, Goog, egg, apple, together as one go. As I said, lists can be of anything, including other lists. So there are very verbose data structure. They can be the basis of trees. They can be the basis of other structures like queues or stacks, if you want to do something in that location. In fact, the idea of using a list as the basis of the data structure is so common that if I take symbols, right, and I look again at the functions which are defined on a list, okay, we've already talked about appending and index. There's actually one called pop, because you might be familiar with a pop is something you would do in a stack. So if I have a list of symbols and I pop the first item off that list, what a pop does is it takes the top of the list and removes it, giving it back to me, while at the same time removing it from the list. So if you wanted to implement some sort of stack, right, you can use pop to pop things off the stack. Oh, right? And then you can use append to put them back on the stack. Right, so what I've done is I popped it off and then I appended it back on. So already it's a queue. You could do an algorithm based on queues. Those of you taking data structure courses would know all about this. Okay, so we've got lists of lists, we've got indexes of indexes. That's sort of the idea. I believe you can actually do something which is even weirder. So here is my list. Okay, so let's say I've got some data, 3, 4, 5, 6. I think what you can do is you can append itself. Now, this is a bit weird. Okay, so my list now has 4 things in it. Okay, so what are the things? Well, they are these numbers. My list 0 is My list 1 is the second character. My list 2 is the third character. And what list? Itself. So here is a recursive list. The list contains a reference to itself. And if you know anything about linked lists, you can see how this can be the basis of a linked list data structure, right? Where you can have a list represent some node, and you can have links to links. You can have graphs. You can have circular graphs. You could have asymmetric graphs. You could have all sorts of things can be constructed using lists. Again, it depends how much programming you've done and how much computer science about what you want to get into. Okay, so those are strings, and I think one more type of data that I want to talk about before we get sort of into a worked example, which is file management. So what we talked about as data types is numbers to 2.4. We talked about strings, okay, which are immutable. Numbers are also immutable; they can't be changed. And we talked about lists, right? So a list is any sequence of things with a square bracket, and these are mutable. There's one other type you almost always need, which is files, right? When I actually go onto my hard drive and I take a look at what's here, here is a bunch of files. There is some data. How do I get that data into my environment, right? So here's a subdirectory. Let's just go inside of it for a moment and explore. It's got a bunch of files in it, a bunch of CSV files. How would I go about loading that data in? Well, the way we do it is we use open, okay? So to open a file, what you do, running Python again, is you open a file with whatever name you want to call it, and then you can open it with certain conditions. You could either open it for reading and writing text, as opposed to reading and writing binary. Oh, well, that file didn't exist yet. Oh, so let's try the other one, which is to open a file for writing. That will create the file, okay? So G is a file. It has this fancy ring of being a text, but it's something you can read and write to. So if I take G and I write some stuff to it, okay, G was a pointer or a handle to some file on the disk, and I can write stuff to it. Now, once I'm done writing with it, good practice is to close it. Okay, and now G is closed. I can't do anything else with it. But I could take a pointer, and now I could open that file. And this time I'm going to open it for reading. And so there's F. It's a pointer to this file. And like write, there is a function called read. So I can get the text back out of that file. So if you have the ability to write, open, close, and read, you have the basis of input-output all the way through. Now, typically, we want to open files, do something with them, and close them. And so a Pythonic convention is to use something called right? And you can use the with thing. And so if I use a context, what it will do is I will say f.close with open that file txt in read mode as file, okay? What that is doing is the same as saying file equals this thing, then I can do whatever I want to do. Oops. Data, this thing. And then when I'm done, I don't need to close it because context will automatically close it. So the file's gone, it doesn't exist anymore, and I'm left with the string of data, which was inside my file. So a typical way of using a file, use a context like this. So the idiom I just typed out, you're reading a whole file. If you want to read a file line by line, files understand this idea of iterating through them. So if you want to open up a file, rather than reading the entire file in one go, what I can do is I can read a file, each line on its own. Okay, so let's do an exercise together to make sure this makes sense. I want to get into I want to know what directory I'm in, so this is all working. Python has lots of things out of the box. The operating system library lets me do things like get the current working directory. So let's just confirm that if you're following along, you are in a directory that ends practical Python work. Okay, and that's the expectation, is you're doing everything from this subdirectory all the time. Okay, if I want to open up some data, the author's already put some data into this folder called data/portfolio.csv. What I can do is say with open data portfolio.csv. So that's opening a file. I'm going to open it in reading mode. It means I can't write to it. I can only read from it. And I'm going to open it as the variable name f for file. Always have to indent when you're writing your Python code. And then I'm going to read in the entire file in one go, f.read. And then we're going to close the file. It's gone. So now data is all of the characters inside the file. Now, remember escape codes? /n represents a new line. Okay. So even though we're looking at it as a string and it looks a little bit weird, it's actually the first line, then an enter, the second line, then an enter, the third line, then an enter. And what's inside of here is just one big long string. Okay, so this is a single string. And this string, I can use any of the string manipulation things to look for substrings, split, do whatever I want, right? So I could go and do something like data.split on new lines, and I would get out a list where this is the first line, the second line, the third line, the fourth line. Each line is a string that I could then split again by commas. By opening something as a text mode document, you actually have this functionality already. And so if, instead of opening it up in a way where I just read the whole file in as once, what I can say is with open, again, open the file, portfolio.csv, open in reading mode as a text file as f. Remember to tab in. What I can do is I can take each line in the file, and what that's going to do for me is grab the first bit, the second bit, the third bit, the fourth bit. Now it's the entire line, including the /n at the end. So if I say print line, okay, you see these extra spaces? That's because print on its own prints a string and then adds in a line feed to actually advance the screen forward. So if I wanted to do all this kind of stuff and not have those lines printed, whoa, I hit a key. What I can do is I can say, you know what, at the end of every line, I don't want you to put an end return, I want you to put an empty string, because the line itself contains the /n. And so it's a way of reading things line by line, okay? So you can start to process these things. Now, the way that it works is when you do a for, inside, there's this idea of a next. Okay, let me be clear. I'm going to open up this file. Open data portfolio.csv as reading and as text. Okay, so I said this is a pointer or some thing that represents the file. You can read the entire thing in one go, but we're not going to do that. What we're going to do is we're going to use the function next. So what next does is it extracts the first line represented by.
Hello, Professor. You are muted.
Oh, I know. There you go. It just decides whenever the internet cuts out to mute me. Okay, I'm back, no problem. I could either use next to get it, or I could use this idea of list doing a loop through all the remaining elements, okay? So when you use file IO, you're pulling out the first line, and that moves what's called a file pointer down to the next line. So if I use a for loop for line in F, and I print out that line, okay, it'll do the successive lines. So this is an important bit, that once you've opened the file, you are now at the end of the file. So if I was now to do next of F, I don't get anything, okay? Next of it, well, there's no F, right? What I have to do then is I either have to close the file and reopen it. So if I reopen it and say next of F, what I'm getting is the first line, the second line, the third line, the fourth line, fifth line, sixth line, seventh line, eighth line, and then that's it. So that's how for loops are actually working. They're actually just calling next of F on this data structure, pulling them all the way out. Now, there are ways, if you look at the arguments of F, you can do what's called a seek or a tell to actually change and go back to the beginning of the file and modify it. But generally what I would say is, once you open a file, read through it once, don't go back and forth, right? Just think about the file being read once and you're going through it line by line by line, all the way through. Okay, so we can continue to be a little bit fancier with our processing of this file. Okay, so I've got some data. What I can do is I can open up that file and I can get out the header information. So we've already figured out what headers look like. Headers is those pieces information and split it into 3 pieces where each piece represents a different part of the phrase. So headers, rather than thinking of a single string, take headers and split it by comma. So now headers is 3 parts: the first column, the second column, the third column. And likewise, if I've brought in my data, okay, I get the first line out of it, then I can loop through it. And for each line, I can take the line, split it into pieces, and then I could print out the whole sequence. And now you're seeing that I'm getting the first thing, the second thing, and the third thing. This is a way of processing what's going on. Okay, so I'm looking at file manipulation. Okay, now we're going to try and do something. We're going to try and write a program, okay, that reads in portfolio.csv. And what it's going to do is it's going to calculate the total value of all of those portfolios, right? So what you're going to do is you're going to figure out how much this portfolio of stocks, different stock amounts, different prices, how much is this worth all the way through? And so what I want you to do, and you can go and do this right now, and we'll take sort of we'll take it up in 10 minutes. We'll just sort of stand up, stretch, either code this up or walk away. Write a program called pcost. Okay, and so what do I mean by that? Inside the work directory, there's already a file called pcost. I'll open it up here. It has nothing inside of it. Oh, code, there's pcost, there it is. There's nothing inside of this file. I want you to write a solution, and it's probably going to start F equals open data / portfolio.csv read T. Okay. Write some, by the way, write some code. No, not that. What's that? Your code here. Okay, so that the output, okay, PUT, the output is that phrase. Okay, and so let's get back together here at in 8 minutes, just a short little break at 1, 2, 30 Newfoundland time. We'll take that up as a group. So how about you work on that, or wait till later if you see a stretch break or a bathroom break, and we'll get back to this in 8 minutes. Okay, let's get back at this. How about rather than just hearing me natter on as I've been doing, let's grab someone else in the room. It doesn't even matter who it is. Would someone be willing to share their screen and show us how you would solve this in Python? How would you do this loop? And if you're in the middle of writing it, I'm fine if you live code it. Volunteer. You're a silent bunch. No one's got their camera on. I don't even know if you're physically there or not. Oh, this is bad. Okay, learning by doing is always better. But not hearing anybody willing to go forward. Would you rather just be doing it on my screen?
Hello, Professor.
Oh, wait. Oh, who's that? Who's the brave soul?
So my name is Prithvi.
Yay! Thank you. It's just I said it's always useful to see someone else's code rather than mine. Great.
Right. So this is the solution
Yep.
that I did.
Yeah.
So the first
Exactly.
thing is, this is the line that we need to do to compute the total.
Exactly. Exactly.
And this is the solution.
Beautiful. The only, and it's very tiny. When you're done with a file, always remember to close it.
Right.
Yeah, and that's just good practice. Like Python will close it for you, but you just should do it in f.close. But that's exactly right. So what are we doing? We're opening the file. We're taking up the first line, just the headers, because we're going to ignore that. We're going to have a variable called total. And then we're just going to go through each line and get the second column and the third column, multiply them together to get the total cost. Exactly. Real simple, real easy. Thanks very much. I really appreciate that.
Right. Thank you.
Yeah, all good. Okay. So let's just really just finish off, share screen. Okay. So just to finish it up here, there are obviously other kinds of files other than text files. If you had to read a compressed file, say something that was a gzip file, you actually have a way of opening a file within the gzip module, so it'll uncompress the file on the fly. So you can imagine having a data portfolio.csv that was very large and it was compressed. Now gzip is similar to zip, similar idea. We've been using open. If you use gzip.open, what that will do is uncompress this file, read it in, and do stuff, but never actually uncompress it on the disk. So you can leave the file as a compressed file on the disk, and it's only uncompressing it in memory. So these kind of ideas are useful. If you want to do things line by line, we have to open up as text files. If you open them without that, it'll open them as binary files. Now, in practice, when we're dealing with comma-separated values, CSV, there is a library out there called pandas, and that's what everyone would use to do this. But the point of these exercises is not to learn about analyzing portfolio stock data. It's to learn about how Python thinks and works with data types, which is why we're doing this. The final little entry in this sort of introduction is recognizing that often when you're coding, you'll have things you want to do again and again. Okay, so for example, let's say that you wanted to have a routine that returned the first n integers. I could write this code out write in a Python environment, right? I am totally able to just say total equals 0, and then say while n equals 10, while n is greater than 0. We've seen this kind of construct before. Total plus equals n minus equals 1, and I could run it and then take a look at total, okay? And so I could run this if it was a one-off. And we know that it can be simpler or better that to take a file, not vi, I'll say colon sum count. I may take that same sequence of instructions, and I might throw it into a file if I want to use it again. So I'll just copy and paste this. All right, and again, I'll say, okay. Okay, so there is Python sum count 55, because that's the sum from 1 to 10. So let's be a little bit fancier, is total. Let's use some F strings to make that program a little bit better. Oh, I must be missing a quote. So you see these pieces work together. Right, to n, no. Let's do it like this. 1 to n is space n equals quote. There's a dozen ways of doing this. Now there must be a string I'm missing here because it's not formatting correctly. Yeah, but it basically works, right? So the sum of 1 to 10 is 55, and then I can come along and I could change the program here, right? And I can make that a 13, and now the sum from 1 to 13 is 91, right? So I could write some program that does this, and this is a little bit better. But what if I wanted to figure out the sum of lots of numbers and do this again and again and again? Well, what we'd want to do is we want to take this little routine and wrap it. Okay, what's the error? What's it complaining about? I'm just gonna Control S, save that, because it's not liking it. I don't know why. I don't think there's an error. I think it's just a rendering issue. Okay, so I got a little program. What I can do is I can wrap this bit of code in something called a function. For a function, what you use is use the def keyword. You give it a name. You give it any arguments you want, and then you give it a colon. And anytime you see a colon, you have to indent after that. And then you can return whatever the answer is. So now this that you could call again and again. Program a little bit so that I've got this function, which is a rule that takes an n and returns an n. So now I can say the sum total from 1 to n is, now you could do this, total equals sum count of n. Clean it up a little bit. Let's just test my program. Well, that's not very good. Oh, not return n, return total. Right, so the sum of that works. You could be even a bit more tight if you wanted. Right, so the sum from 1 to n is sum of count n. Right, there we go. And so that means that I can now maybe reuse that code. What's the sum from 1 to 100? Right, 50-50. And the idea here is anything inside of this def is a block that can be repeated. You can replace whatever you want. So def starts a function, then you've got a name, a sequence of arguments, a colon, and at the end, you return back whatever that function needs to do. So it's a way of reproducing your functions without having to be in separate files, but you can have multiple functions within the same program. In fact, those functions are exactly what these library things we've been seeing are. When we looked at the square root function or URL request, these are functions, and these functions are being defined with defs. Now, they're all being grouped into module, a whole bunch of functions together, and we'll get to that later on. Okay. Now, there are errors that sometimes need to be given, right? So let's imagine I'm running this program, and I run a program that makes no sense. Okay, I say not applicable. Okay, so what if I tried to run this program, the sum count of not applicable through this whole program? Internet. Okay, I unmuted myself, we should be back. Okay, so you could run this again, and the error is occurring on line 3 of sum count, and the problem is n and 0. Well, if n is a string NA, it doesn't work. It doesn't know how to handle that, right? So what we can do is we can try and handle this situation. So maybe what we want to do is we want to say, you know what? Try first to say n is an integer of n, right? And if that didn't work, okay, if you were not able to convert that number into a number, okay, except if there was a certain kind of error, right, value error, what you could do is you could print a meaningful debug message. N is not a valid integer. So this is the idea of handling errors in your program. You know what? How about this? We'll use format. There we go. And we've added a little bit of debugging information. NA is not a valid integer. Oh, I don't want to keep on running the program. I want to stop. So you know what? How about we just return? Okay, so try and do something. If that works, go to the next part. If it doesn't work, give me an error message and then just stop. Okay, so I'll show you what that does. So now what happens is the program is handling that error. It's saying, I'm expecting n to be an integer. If it's not an integer, then handle it in some way. Now, I talked about being Pythonic. In Python programming, we don't tend to do this kind of testing for the characters. We actually use these exceptions to fail first. So typically when we're writing Python, you write the code as if you're doing it correctly, and you use these exceptions to tell the calling program something wrong has happened, right? So we wouldn't usually print out a message. What we would do is raise up some other exception higher up in the stack. And so you can do that where you can try and raise your own kind of error all the way through. Anyways, but that's sort of more advanced in terms of debugging. Let's just make sure that we can define our own functions. So here is an example of a function, okay? So if I open up a function and I say def greeting, and then an argument, and then a colon. And remember, everything in functions is indented. It's always indented by 4 characters. In this example, there's string. Choose greeting by itself, and then tab, print hello name. Okay, so greeting is now a function. And you see it says function greeting. And if you put in an argument, and I say, hi there, Guido, or I say, hi there, James. Whoops. Oh, come on, put my own name in there. What it's doing is it's calling this function. But here's a question. What is this thing doing right here? Well, what it's doing, remember when we were talking about help? There is built-in help on everything, including yourself. So the help string issues a greeting, okay? I added that to the automatic help feature by putting it in as the first string inside of a program. So the way that this works is the first string, and the strings can be either with single quotes, or double quotes, or triple quotes. This function sums the numbers from 1 to n and returns the total. Okay? Because this is the first statement, it's just a string by itself that doesn't do anything in this program. If I try and look at the help of this thing, print help of some count, you actually see that what gets printed out is the help. This function sums the numbers from 1 to n, right? And it's doing a whole bunch of little fancy things for me. It's giving me the title, it's putting the arguments in there, and then it just takes whatever text I put right here and makes that the text. So all Python functions have something like that. Now, if you leave this out, okay, if you get rid of the documentation, you have no documentation. Then the documentation is very, very boring. It's not like it can think for itself. You got to supply it. But that's how you can make your functions self-documentation. So these are called documentation strings or doc strings, and they're fairly common. Okay, I will leave this exercise for you to work on. Take this pcost function that you wrote before and turn that into a function. So whatever function you had, turn it into something that takes an argument, which is a file name, and this becomes your function. So that when you run this program, you can interactively work with it and get the data. So again, when you're doing these exercises, the idea is you have an exercise, you write the solution, right? For line in F, row equals line split. What did we say? Total, I'm just trying to remember whatever they had. Total equals plus row 2 times row 3. And you know what? These need to be floats. Print and total cost is, and then total, and then 2 strings and an F. Okay, hopefully I did that correctly. Oh, wait, because there's 3 items. So it's item 1 and item 2. Oh, I didn't like that. There we go. So there's my program. Once you've done exercise 1.27, remember that what I want you to be doing is taking that, putting it into Git, doing commit. Completed exercise 1.27. You've saved it. Now, when you come to step, exercise 130, take your program, modify your program so it's saying which version it is, and turn this into a function. So you want to have some function that goes def portfolio file name. Okay, and all this has got to be indented. Now do whatever you need to do to make this program look like this program. And then when you've got that working, commit it all the way in. And then it's asking you to do some error handling, right? And so what they want you to do is modify PCOS to catch an error and print a warning message. So I showed you an example of doing that, right? Use a try except loop, so you can try and figure that out. That's a separate module. It should be a separate commit. And finally, you can try and see what the CSV function will do. CSV will actually handle this all the way for you if you want, which means once you've written that, modify PCOS to use the CSV module. And what the CSV module is going to handle is handling all of this conversion stuff. This stuff's messy. Which column am I in? Am I a float or an int or a string? How do I do the split? The CSV module handles all of that lower level stuff. So the idea here is that this assignment is to do these steps step by step, and every time you've done it, you've committed it in. So this is sort of best done in a group, and if we were in class for a whole day, I'd let you work on this and I walk around the room. I don't know how beneficial that is in this remote sort of way, so maybe I should just let you work on that on your own, and we can take it up. Okay, so that concludes this first chapter of the Python stuff. What I want to do now is take a little bit of a break from Python and review one of the topics we did last week. And it really gets into this stuff, the get add, get commit. And once you've done a bit get commits, remember you can do a get push, and that actually pushes it up to GitHub so that I can see what you're working on. Okay, and what do I mean by that? I'll stop the share. I'll share my entire screen so you can see everything that I'm working on. It means that if I go to someone's account, here, I was going to write a note out to you. You know who you are. It's not your actual name. So here is someone's account in the class. I go to repositories. I'm expecting to see the words practical as one of your repositories. If I go to my repositories, I got lots of repositories, right? One of them is practical Python. And if I go to this thing, I should be able to see your commits, right? And there you go. There is what you completed for exercise 1.27. And I can go and actually take a look at what you did for that commit, right? And I can see that what this commit was the adding of these lines, okay? So I'm just going to pick some people. I don't know who I got here. You know what? I'm just going to go down in order of who I see. I don't even know if it's alphabetical. Probably in order of who joined. Let's just grab some people here. So right at the top of my list, Arnab, you're at the top of my list here in Slack. There's your name right there. So if I was to go along and put in, now I know that it's not Arnab, and this is something that I've had to decode. That is not you. That is some other person. Hold on. Private. See, what I went and did is I created a class list so that I look all this stuff up. Okay, and I can go in my little list and I can find a person. Of course, you're going to recognize it before I'm going to recognize it because you know where your name. There we go. ABRUA. I picked a person from the class. So I can go and just pick someone from the class, and I can see what they're currently. Oh, well, that's problematic. Arnab, is this you? Do I have the right person?
Professor, it's A.R. Barua. A.R.
A.R.
Yeah.
There you go. Okay, and this is the problem with GitHub routines. I must have copied that wrong. What did I do? Oh, this is your MUN ID. This is your GitHub ID. Aha. And that's why I had that lookup table for myself.
Yeah.
Okay, so this is an example. I said I'm just picking on you, but this is great. Example of something that's what I want to see, right? You're working on your GitHub repository, and here's your practical Python. right? So I'd be able to go in here and look at commits, and I'd be able to see if you've worked on this at all. And you haven't worked on it yet, which is cool, which is fine, but you're going to show some commits in here to sort of see how things are going, right? So that's the idea. So everybody should have forked from this original one. You're committing to a public branch on everything. And I'm just looking for activity. I'm just making sure that you've worked through these exercises. And really what you should be building up is a mortgage.py, a pcost.py. It turns out that this particular set of exercises, because we all come from different backgrounds, it's just based on money, stock prices, something, you know, you're all eventually going to be invested and be worth lots of money. It's a pretty generic kind of mathematical operation, which is why we're using it. But this is where to put it. While we're talking about that back and forth, what I want to do is I want to talk about Git and GitHub and how it gets used. And so the way that we explored this is you've now created for me 3 repositories, right? One repository is this public one from the Git assignment, which is due today. One is a private repository that you're going to have all your assignments in that is like personal information. And that's private, where you shared it with me, so you can't see your classmates, which is good. And then the last one is this one you forked. So you've already got 3 different repositories up on GitHub. So you know what? Let's make a little panel here. So Arnab, you're one. I need 2 other volunteers.
I can volunteer as well.
Who's that name? Mike?
Mike, yeah.
Sure. Okay, Mike, what is your it's probably an M.
Yeah, MTK282.
M2K? No.
TK.
I can't. You're saying it 2K. Okay, you went with exactly the same thing as your MUN ID. Fantastic. And you've got 3 repositories. Okay, I need a third people for my panel. Oh, I have one. Someone just volunteered. Thanks very much. I appreciate that. And this is going to constitute your participation mark. I basically try to choose 3 people a day to have you say something. We have a GitHub user. Look at this. You got like, okay, you're not a big GitHub user. You took a class in 2013. Is that right? Okay,
yes,
so you have a little bit of GitHub activity. It's
Yeah.
something, right? It's a way of showing the world who you are and what you've done. So I've got 3 different GitHub identities out here. And what I want to do is use the 3 of you, as a little panel discussion, okay? So the first question I'm going to have, and we'll just go through each of you, is have you used version control before? And so we'll just go Arnab, and then Mike, and then Vivek, right? So have you used version control before in any system?
No, this is my first time.
Okay, no problem at all. Mike, have you used a version control system before?
No, using in this course to be the first time I used it as well.
Okay, and Vivek, is that right? Other than this little bit of starting stuff you did last year,
Yes, I
do
use
you
it
use
before.
version control other places?
Yeah, so I'm working part-time with the NRC, so I have a different GitHub account with them, and I'm using
Right, but you're
over there.
using a different GitHub account for that. Okay. So one of the things about GitHub is because it is a social environment, you actually can use the same account and be part of lots of different organizations, right? And what that does is it lets you build up an identity that's going to carry with you outside of where you happen to currently be. So you're able to see what people have contributed to, whether or not be open source or private, sort of going forward. Now, NRC, you might all be closed and it won't matter, but generally these tools are good. Okay, so Vivek, you're working part-time. Arnab and Mike, what programs are you in? What degree programs?
I actually doing my research on machine learning. So I have
Research on machine learning. Okay.
yeah.
Okay.
So I have
are you
pretty
are
knowledge
you a
about
master's?
programming.
Yeah,
Yeah,
but
I'm
you're a master's of computer science student.
yeah, Masters of Computer Science.
Gotcha. And Mike, are you coming from a different discipline or?
So I was doing my master's in geophysics, but I recently transferred into a PhD program. So now I'm doing a PhD in geophysics.
Gotcha. Okay. So we have someone from a machine learning background. A bit new, but it's bigger and bigger. If you're doing a PhD in geophysics, you know you have to publish. And one of the requirements that's coming down the line is the request that more and more of our science be open. One of the places in the world to put it is GitHub, as a way of being out there, shared, where people can do it. And it's better than just being out there. It's out there in a way that if someone takes it and then does something with it, you actually get to see where that work went. So for example, Practical Python, we're copying it because it's under a Creative Commons license. But look, this 3,600 people, this author is able to know that 3,000 different people have at least looked at his material. And some of them might have gone on and made modifications to it. So using these kinds of systems, it doesn't have to use GitHub, it could be another one, is a good way of taking your published work and getting it out there. Okay, I'm gonna pick on Arnab here for a second. You're doing machine learning, which means I'm sure you have done courses where you have had to write code. Is that true?
Yeah.
Okay, have you ever had to do any group projects?
No.
No, you haven't had to do any group projects yet.
Yeah, I had to do
project.
group project. No. I have done group project in a course. It was named Computer Graphics in the last semester.
Oh, computer graphics. That's perfect. That's perfect. Okay. So here's my question to you. Yep. So here's my question. If you've never used version control before, how in that group project did you collaborate among your group? How did you share what you were working on with each other?
We actually held a meeting. The meeting was like for 3 to 4 hours long, and we actually did it before the project for 3 to 4 days. So every day, 3 to 4 hours long, a live meeting. So my partner was doing the coding, and I was helping him by solving some logics. But most of the work was done by him. But I actually just finding out if there was an error or not.
Yeah. So your solution was basically to have, for multiple people, only one person touching the code, right? So it was your brain, but one person was actually using a keyboard. So the files were on one computer, right? As soon as you get into projects that are bigger than these academic toy projects, you start to have lots of people working on it at the same time. So just as an example, because I'm currently going, I'm on a conference right now, a 3-day conference on this piece of software called Dask. There's a Python library. I'm attending a conference about it right now. It is a library that lets you do multiprocessing in Python. Okay, so here is its Dask page. Okay, so the library is called Dask. There has been 6,000 different contributions to this project, okay, by lots and lots of different people. So you see each name here, QS, Jerkam, Penchev, Mad, things. Each one of these is a different person out there in the world who has made some contribution to this code base. And I can see exactly who has made a contribution each one. And in fact, you're doing something on this fellow has actually done the most go down. Way of allowing multiple people to interact between it back and forth. So one of the things you're practicing here in this course is using Git, which is different than GitHub, and don't get confused. Git is the version control system which is distributed. GitHub is a way of a social network / a way of hosting Git repositories so people can interact back and forth. We're practicing using those things because that's how we develop code within a group, over time, and also with the community, right? So if we're doing open science. So for the purpose of this course, get in the habit of when you make changes, push them. Like you're doing lots of commits. So the number of commits is going to be like hundreds, would be fine. You're just going to be committing all the time. We'll try and do a bit of group work in this course where I'll have 2 or 3 of you working on the same Git thing, going back and forth. So it's the idea of collaborative working on something, and this is how it's done in practice. Now, these tools, there's a lot more to it as well. It's more than just Git and Git commit and Git add and do things. GitHub adds in function issue tracking. So any modularly, any project which is of any size at all will have many open issues. So right now there are 668 things that are wrong with this Dask thing, and this is open source. Anybody can come along and be like, I can fix that. And you can submit a piece of code called a pull request saying, here's my solution. So there are right now 103 different solutions to those bugs, which are currently waiting to be reviewed to push back into here, right? So GitHub provides that whole environment. Git is the way of how the code actually gets merged to and fro between the 3 of you. Okay, so let's take this and talk about this particular assignment. So I asked you all to do this assignment. So there is for Arnab, let's go for Mike, and let's go for this one. Okay, so I've got your 3 accounts, okay, and I love to see that all 3 of them have 6 commits. Okay, so if I look at the 6 commits of any of you, I'm sure you have all done it wonderfully, right? So I can see that what you did. So Arnab, right, what did you actually do? You added and removed some lines, right? That was your first change. You can see what's going on there. And it would go along. What was the next commit that you made? You changed some words, and so I'm able to see the full history of what's going on. And then you add another paragraph, and we've got this sequence of what's going on. Now, there's actually 2 branches in your data. So let's go along to another person here. Yeah, you got 2 branches. Mike, this is something we didn't talk about, but was in the documentation. What is the deal with branches? What's your understanding as a new Git user, as a new version control user? What is a branch?
Are branches basically just like almost like different repositories to save things? Am I wrong in saying that, or is it?
Yeah, because they're the same repository.
Right. Okay. Yeah, I'm not totally sure, to be honest with you. I think it's. I guess I'm not sure about the correct terminology for a branch.
Okay, so I'll give it to you this: that in this master branch, this was your very first commit. You see this? Mm-hmm. And every commit, remember, a commit is just a change. Right? So the very first change was the addition of these 4 lines. What the system is doing is saying, okay, I'm going to tag the adding of these 4 lines as commit 7724516. Okay? And in fact, it's a much longer string than that, but that's a unique identifier for the idea of adding 4 lines. These 4 lines. Right? Your next commit had this identifier, and it was the idea or the change of adding these 9 lines, right? This branch is a certain history or path of a sequence of commits, right? 7724, then 878, then this one, then this one, then this one, then this one, right? Your my branch has the same starting point. You see this commit? It's the same. Yes. 772456, but somewhere along the branch, you did something on this branch that you didn't do on this branch. Okay, so I'll flip back to my branch. You see the 495184? That change doesn't exist. Oh, no, it is right here. Can't remember. Well, one of them didn't exist. 9, or you merge them all. You merge them all. Okay, so you have all these changes. And then what we wanted to do is we wanted to merge the branches back. So what you did then is you did a git merge, I think, right? You did a git merge to pull that data back, right? That's what this one is. You did a merge, right? And so a merge took commits from other ones, right? See these two parents? You took these two commits and made a new commit out of them. So what a branch is a particular sequence of history, and actually refers just to a certain point in that history. So a branch is just pointing to the end of a certain point in that history. And you can think of it, a branch as the sequence of all of those steps. So if I want to merge branches, what I'm going to do is I'm going to go to my branch, find out the first commit where the thing is different. And then what the system does is it applies all of those changes on top of this branch right here. Because every change is just a sequence all the way through. Okay, so I'm just sort of getting input from each of you. Vivek, you're not using this GitHub repo, but you're using Git in your day job.
Yeah.
Okay. Do you use branches in your organization?
Yes, Prof.
Okay. How do you use branches? What's the reason for using them at the National Research Council?
Okay, I would say like a medium scale project or any project, like if you are working on any new functionality or a new task, we don't want to disturb our master branch or the main code. So like in a situation, if I want to implement a new feature, I will create a new branch. I will write down all the code and test if the things are working fine. After testing that, I will merge that branch into the master branch. So by doing that, will not disturb the main branch, and our code will save.
That's right. That's exactly right. So you're able to still track history and make changes. And often we'll do something like having a main branch for production and a development branch. But branching in Git is incredibly cheap because all a branch is a reference to this number. So you can branch hundreds of times and there's no expense to it. In other version control systems, a branch actually requires the full duplication of part of the code base. And branching can be very heavy and very expensive. In Git, branching is very, very light. So you're allowed to branch as much as you want. In fact, a normal workflow in a project is to take each one of these issues. And if you want to work on an issue, in some organizations, every single issue gets its own branch. And so you're like, okay, we're going to fix this bug where numpy flip accepts a tuple but does not. I want to fix this bug. Okay, well, how am I going to fix this bug? Is I am going to open up a new branch. Now in GitHub, they have this idea of forks, which you sort of can think of as a branch in another repository. It's not exactly that, but close enough. And what he's done is he's submitted his solution on this different branch. Say it's actually, yeah, here it is. Here. You see this right here? Das main, AS issues flip access tuple. Flip access tuple is the name of this guy's branch on his repo, where he's done a fix for this one bug. So even though there could be multiple commits in this one branch, he basically has everything together so that someone can come along and say, okay, how did you fix this bug? Well, what I did is I have this sequence of commits, right? So we get in the habit of doing this back and forth. Okay, so I'm going to keep on going around. Arnav again. I said, and then I'll put you guys off the hot seat. When you did this merge, this is something we didn't talk about. What did you actually type in on the console to do the branching and to do the committing? And how did you learn about that?
So to create a new branch, I just typed, as far as I remember, git checkout, then -d,
okay,
and the branch name. That was my branch.
Okay, so that is one way of doing it. You can check out a new branch with -b. You can also just say git branch and then name it.
Yeah, I know.
Okay, so to create a branch in the command line, it's just git space branch. And if you look, and there's going to be a million documentations on it, but for those of you who are like, I still don't get this, I need to understand it. I would recommend, and I'll just throw this on a link. I think I already did this on Slack, but I'll just give you a little link to sort of the book on Git. The real basics, okay? The basics are branches are just pointers to this sequence of history, okay? A branch is just a pointer to a certain commit. That's all that it is. How do I go about creating a new branch? Well, what I'm going to do is I'm going to use git space branch. So somewhere in here, if we read through it, there's a git branch. So how do I create a new branch? I just say git branch. That creates a new pointer. Checking it out changes my workspace. So I'm now looking at that. Okay, so once you've worked on a new branch, you've done commits on that new branch, the other question for you, Arnab, is how did you go about taking the changes from my branch and getting them back onto the mainline branch?
So you were talking about merge, right? Like
I'm talking about merge. I'm talking about merge.
Yeah, I just merge the branches. Like I went into the main branch where I want to merge, and then I just type the command git merge. Then the branch I want to merge with this branch, the main branch, the branch name. So
Perfect, exactly.
Like for example, I am in master branch, and in the Professor, you are muted.
Okay, it will give you a, I'll share my screen again, share. It will merge from two different ways, and you'll get a file that will look something like this. And if you've done this, you've seen it. If you try and merge a file where two different commits have modified the same line, it will put this in front of you, okay? And it'll say, look, from the head branch, this was the text. From the other branch, this was the text. Which one do you want? Or do you want a combination of these things? And what you need to do as the human involved is you need to delete one or delete the other or merge them together if that's appropriate and get rid of all this stuff. And then you can do a commit for what that change is, okay? And in fact, there are tooling, if you have a lot of merging to do, that will automatically go through and let you accept A or B. You could look up Git Merge tool, but I find it always easier just to edit this file to get rid of all these symbols to make it look like the way that you want it. Anyways, that's Git merging. So before we move on to anything else, but just the three of you, one open question. Is there anything you find for each of you, tell me one thing you either find odd about Git or exciting about Git? Either something you're like, that was weird, or that's cool.
I think for me, just that's something that's exciting is knowing the power of Git, because something that I do with my research is that a lot of it is open source. So that kind of provides me a place where I can put my research, because once I publish things, I need to basically put my data sets online for people to see it. And then I think Git is the next option for that. Now kind of seeing it, being exposed to it.
Excellent answer.
Yeah, so Git provide a very good platform to manage the very complicated and big code base. So you don't need to I would say you don't need to worry about the version of the code, and it also provides many open source projects. So it's very good.
Okay, and
For me, it seems everything is cool here, because in the past I thought Git is just repository. I'll just use a local cloud storage, nothing else. And sometimes I actually look for some solutions. I found it in Git. So I thought, okay, people actually restore their code here for others to help, nothing else. But now I am getting everything what actually Git can do. So it seems everything seems cool to me.
Good. Yeah, so Git, for a lot of people, they learn about GitHub as a place to go to download files, and that's good, but it's actually a community to go back and forth in. Now, saying that, as you get into Git, there is a reality about it. So I'm going to just share one little screenshot here. This is Git. It tracks collaborative work on projects to a beautiful distributed graph theory tree model. Cool. How do we use it? No idea. Just memorize these commands and type them in. And if you get any errors, save your work, delete everything, download a fresh copy. That's not ideal, but it is an experience that many people have, especially when you start working with multiple branches and back and forth. As you learn about it, you can handle it. But if you get into a situation where you're like, I don't even know what my current version is, the reality is you can just blow it away and check it out again. It is under version control. This is a normal, common experience. And in fact, if you haven't felt this way about Git, you haven't tried to use it enough. So when you get to this point, just know that you're just normal and you're up to where everyone else is. Okay, that's all pretty good. And 30, we got a little bit more time. Okay, so I am going to give the well, give the three of you a check mark. Yeah, you participated. Thank you very much. I appreciate it. We'll take up some Python stuff next week. And now it is 3:30. What do we have? We have like 45 more minutes, 35 more minutes, half an hour. Okay, so for half an hour, let's dig into a little bit more Python. I know, it's just trying to break it up. Okay, let me share a screen. Okay, let's close all this up. Close this up, close this up, working with data. Okay, chapter 2. So we're not going to do the whole course here. We're going to do the first 3 chapters of this course as a way of getting into it. And so I'm now going to tackle this information. Oh, I lost it. Yeah, there we go. I want to move this around. There we go. You should be able to see. Okay, we're working with data. Okay. So let's just go through these things, and I'll flag some things that I think are interesting. If you have questions about them, we can dive into it. Okay, data types and data structure. We've already been talking today about numbers, integers and floats, and strings. Those are examples of primitive data types. There's one other data type that you'll find everywhere in Python called the none data type. None is a special data type. None is a none. The type of none is none. And it's a way of pointing to nothing. So you have a variable that isn't a number, it isn't a false, it isn't a zero, it's just a null. None and nulls sort of play the same role. A null in other languages. So a null doesn't mean pointing to nothing, it means pointing to a none. It's sort of like a placeholder for the zero piece of data. And you'll find them all around. The way you type in none is the word none, capital N-O-N-E. Functions by their default. Okay, if I have a function, and if I have a function which is like f of x, and I say my function is x, no, I'll say y equals x plus 2, and then that's it. That's the entire function. Okay. If I say f of 3, notice how there's no return statement here. By default, what came back? That y, that's a none, okay? Functions that don't return anything always return none, right? Data structures, as you know from programming, right, are various ways of solving algorithms and solving problems. We can think about a data structure as some combination of things. Some of the data structures that are built into Python, one of them is lists, we talked about before. A tuple, and the word tuple is based on the idea of like a triple or a double or a quadruple. So a tuple is a collection of values grouped together. It's a generic idea of a sequence, but a tuple includes not only pairs of things. Okay, so that's a double, a tuple. It can contain long lists of things. Okay, it also can contain a very short list of things. So there is a tuple which only has one element in it. So that's a oneple. And in fact, there is a zerople. There is a tuple which has nothing inside of it. Okay, it's an empty collection because sometimes you need collections that are zero. Why do we have a list and a tuple? Okay, because at first glance, A is a list, B is a list. You can take the length of A, you can take the length of B. You can say, what is A article question number 2? You can say B number 2. They act a sort of the way. The difference is how they're stored in memory. Lists are mutable. Tuples are not. You can't modify a tuple. So a tuple is something which exists. It has an order. It's the first, second, third, but you can't modify it. So lists are modifiable sequences. Tuples are non-modifiable sequences. And you might think, well, what's the point of it? It has to do how memory management in Python works. If you have a tuple, then because you know it never needs to be copied, all versions of it can just be, all variables pointing to it can just be pointing to the same data structure in memory. Lists, you can have copies of things all the way through. So it's how memory gets moved around. So we say that tuples are immutable, like strings, all the way through. You can always make a new tuple based on other tuples. Tuples come up lots in Python because they're how we pass multiple values back and forth. So if I have a function, okay, so here is my function. Let's see here, I'll function n, return back here, and I'll return back an answer, return 1, 2, 3, and 4, okay? So f of some number, it's returning back a tuple. This is how I pass back multiple pieces of information. If I have a function that says color equals blue, number equals 5, and place equals Winnipeg, okay, what I could do is I could return back the tuple color, number, place, okay? So if I run that function, I get back 3 things. The idea of tuple packing is I can go color, comma, number, comma, place equals f of 3. And what will happen is the arguments of this, 1, 2, 3, get assigned to the variables color, number, and place. Okay? And so color is now blue, number is 5, and place is Winnipeg. Likewise, if I have something which is a tuple, I can actually use tuple for passing multiple arguments into a function. And that in some ways is what this is doing, okay? When you have a function, that's not quite a tuple, but it's pretty close. It's a sequence of things. It's a first thing, a second thing, a third thing, a fourth thing. Now, arguments are not tuples, but it's one way of passing an arbitrary list into a function. You could pass it as a tuple, so you could pass in one data struction and get a lot of stuff in. So let me modify def. I'll say my data, okay, and we could say print my data 0, print my data 1, print my data 2. So there's a function, okay? So if my data is a tuple of multiple things, I can say f of my data, and the 4 can get unpacked as the first thing, the 3 can get unpacked as the second thing, the 5th can be unpacked as the third thing. So it's a way of passing multiple things in and multiple things out with tuple packing. Now, again, tuples look like read-only lists. But typically, I would say in a Pythonic way, a tuple is typically used when we've got a single record, right? A single item that logically needs to always be kept together. So a tuple is used when you've got some data where one piece of the data it doesn't make any sense without the other parts, right? So when we were doing earthquakes, remember we did the earthquake data? Okay, we did the earthquake data for assignment number 2, which, by the way, I'm halfway through marking, and you will see your answers in GitHub. I will upload my comments to it. Earthquake data, what it might contain is a year, a place, and the magnitude, right? So that is a particular record, and because it's all joined together, we might represent it as a tuple. A list is something that's typically used if it can be talked about differently, right? So if I want to talk about countries, right, I could talk about Canada and the USA and Middle Earth, right? I'm not sure if Middle Earth is a country or not. It's not a country. That's wrong. And apologies to all Tolkien fans. Middle Earth is the whole world. But we'll go with it. We typically use it as a list. So one of the things that can happen is you can have all the data might be made up of a list of tuples. All right, so here's a common sort of thing. Oh, I got some bracket issues. Open square, open round, close round, open round, close round. Oh, there it got hidden. Got hidden. Right. So there is a situation where I've got a list of tuples. So this is a very common thing because this is a record that sort of needs to be kept together. We'll use it. Okay, so lists and tuples. The other one that pops up all the time is what's called dictionaries. Dictionaries are key value pairs, otherwise known as hash tables or associative arrays. We declare dictionaries using colons. So we have keys and items. The rules are with these things is this needs to be some immutable type. Whatever's on the left-hand side here, the key has to be immutable. Strings, numbers, tuples. This on the right-hand side can be anything we want. So what I can do is I can take a construct like this structure right here. Now S becomes all of that data. But what we've given up is we've given up any sense of order. There's no longer a concept of the first thing or the second thing. That doesn't make any sense. Now things are indexed by their keys. So the name of this share is Google. The number of shares is 100. So it's a different way of doing the lookups. You're looking up not indices 1, 2, 3, 4. In some ways, you can think of a tuple. Okay, when we talk about a tuple, of say the data round bracket A, comma B, comma C. Okay, so this is a tuple, right? You can sort of think of a tuple as being a dictionary of the form 0 maps to A, 1 maps to B, and 2 maps to C. Okay, so that is a tuple, that is a dictionary, but they're going to behave the same way. A of 2 is C, D of 2 is C. It's sort of a similar idea back and forth. So it's a name lookup. And again, what goes on the right-hand side can be anything. You can put a list over here. You can put another dictionary. But dictionaries themselves are mutable. You can add keys to it or remove keys from it. So you can't use a dictionary as a key, so you can use a dictionary as a value on the right-hand side. Okay, so you can look things up. It's a great way of storing data. If you want to get rid of something, we've got a del. Dictionaries are used everywhere in Python. It makes your code a lot more readable. So sometimes you'll have a list of things, like in this piece of data about the record. We talked about the earthquake data, right? The first thing is the year. The second thing is Middle Earth. The third thing is the magnitude. Wouldn't it be easier if I labeled these things as a year, 2021, as a place, Middle Earth, and a magnitude. All right, earthquake data. So now I can talk about earthquake data of the place. And there's a way of doing a lookup from this identifier to this word. And so you don't need to care about the relative order. And in fact, dictionaries have no order built into them. And so there's an exercise here for you to play with that. If you actually take a look at the CSV module, you see that what it does is it reads things in as lists, okay? So lists are the square brackets. And if you wanted to store that as some other data type, what you might do is you might unpack that as a tuple, okay, where I've done a conversion, or I may want to unpack that thing as a dictionary, right? So I can use a dictionary to store those sort of values. So I will leave those for you to play around with, going, okay, how does this work? Read through it, try it on your leisure to do it. Keys, this idea of keys, any dictionary, earthquake data, right, has two ideas. It has the set of all of its keys, year, place, and magnitude, and it also has the idea of all of its values. Okay, oh, not zero, values, right? So here's the first key, the second key, the third key, the first value, the second value, the third value. So if you ever wanted to iterate through everything, you either could iterate through all the keys for key in earthquake data.keys, and you could print out the keys, right? Or you could take all the keys and you could print out maybe the key and then the earthquake data key and do the lookup. But in fact, this is so common that there's actually a variation, which is key, comma, value in earthquake items. And what earthquake items is going to do, and this is combining a few different ideas together, is items is going to give you a sequence of tuples. And the tuples are the key, comma, the value. And so that means that you can, for key, comma, value in earthquake items, print key, comma, value. Earthquake data, comma, items, print key value, right? So there's just ways of iterating through these things. Important thing about dictionaries is there's no order on dictionaries. There are other data types out there which are ordered dictionaries should you ever need them. Okay, these data structures are all examples of containers, okay? Whether or not it's lists, which we've talked about, or dictionaries, then there's a third variety, which is I want a mutable set. I think sets are mutable. Let's just do it. A set is a sequence of things. No, a set is a collection of things. Blue, red, yellow. Okay. Where a set uses just curly brackets with no things in it. And there is a add method. So that tells us that sets are mutable. They can be modified. But they've got this neat feature that you're guaranteed that everything in it is unique, right? So if I add to this list of colors that are already in there, nothing happens. What you give up is you give up ordering. So there's no thing as the first, the second, the third, and the fourth. This is just a straight sequence. Why would you ever want such a thing? Because maybe you want to do something with sets and you want to do with intersections or unions, right? So here are my fave numbers, and my favorite numbers are going to be 2 and 7 and 8 and 7, 3 and 2. No, 2 and 8 and 8. Let's make this a set. Your fave numbers, I don't know, 1, 2, and 3, and 4, and 5, no, 4, and 8, and 6. Okay, our fave numbers, what are those going to be? It's going to be my fave numbers intersection with your fave numbers, right? It's the numbers that are in both of these two sets together, right? What are the numbers that are in these two sets together? Well, 8 and 2. So anytime you need to do set operations. Okay, so these are all ways of holding on to things They're all mutable. They can all have things added to them, removed from them. You can ask questions like, is something inside of it? And so often what we'll do is use a list as a container of things, and the things could be tuples, right? So if you're talking about a stock portfolio, maybe what you want to do is have a whole bunch of portfolio items in there as a collection. Okay, what do we got? So lists can be built explicitly. So here's one way of coming up with a list, and we've seen this before. I do it with the earthquake data. Where's my example from earthquakes? Yeah. Oh, that's not one. All items. I can't find it. I'll do it again. I'll just do their example. Portfolio. One way of building a list is to explicitly have the list written up. So you have the first item, okay? Google 100 490.1. Okay, that's the first item in the list. Here's the second item in the list. Here's the third item in the list. And when you're done making a list, a square bracket closes the list. And then I've got a list, portfolio. And again, there are 3 items in that list. And I can talk about the first, the second, or the third. I also could build up the list by starting off with an empty list. Okay. And then adding to that list these records. And so what I'm going to add this first record. And so now records has one thing inside of it. And then I could take records and I can append a second thing. And you can read it in. And so you can see how this kind of notation could be used when you're reading in from a file. When you're reading in from a file, you could open up a file, read in the line, get out that line, parse it, and then append to your list of records all of the information. The name of the stock, how many shares you have, and what the price was when you bought it. So lists is one way of doing it. Dictionaries are another way of doing it, right? Where maybe you had a dictionary, which was the current price of Google and this stock and this stock and this stock, right? There's no inherent order to it. It's not that Microsoft comes before Google or before IBM, but it's a one-to-one mapping. I want to know what the price is of Google. I look it up. So dictionaries have that ability to do lookups of things. So different data structures tend to be used Pythonically in different contexts, and it's just experience to learn which one. Like lists, you can either do them explicitly all in one go, or you can do them in pieces. So in pieces, what you do is you just have an initial empty dictionary. And I know it's weird. And in a set, okay, 1, 2, 3, that's a set. Okay, so if I say A, 1, 2, 3, and I say type of A, that is a set. And if I say D is a dictionary, D1 maps to 1, okay, that is a dictionary. That is a dictionary, which is a little bit weird, but they needed to choose which one of these things was going to be the empty one. So that's an empty set. That is a set of nothing. Turns out there's actually an empty dictionary and an empty list as well, should you ever need those things. But that's how they've done it. So if we're reading in prices, what we could do is open up some file, read in each line, and then add things to a dictionary. And what the dictionary is doing is it's doing insertions. This is the key, and that key has never appeared before. If it never appeared before, it's going to be added to the dictionary. If it has appeared before, it's going to do an update. And the last thing you need to know about a dictionary is if you have a dictionary of things, okay, so let me come up with a dictionary of things. Okay, so here's my dictionary. I may want to ask a question like, okay, is this stock, AAPL, is this in my dictionary? I could just try it and get an exception called a key error, right? That's one way of doing it. But if I wanted to check, what I could do is do a lookup. I could say Apple in prices, and that will give me a true or a false if it's in the list of keys. Google in prices, right? this will do the lookup. So if I needed to, for some reason, test whether or not it's there or not, I could do so. And a final sort of little case is sometimes what you want is look up the key, and if it's not in there, give me a price. So what I could do is I could say prices, get, well, let's say Goog. That's the same thing as prices Goog with the additional functionality that I can add in a default. So if I didn't know what the value was, I'd return back 0. Prices get Apple, right? 0, because it doesn't know about it. That's entirely possible. The trick is about these keys. Keys can be anything that's immutable. So what does that mean? Numbers can be keys, strings can be keys, tuples can be keys. So anything that is one of those kind of data structures is allowed to be a key in that system. But I think we're going to say that's a little more advanced than what we need to. Okay. Beyond this, it's just a worked example where you're continuing to modify not just your PCOS program, but running a new program called report.py that lets you grow this thing up. And I'm just trying to see if there's anything worth talking about as a group, or just leaving it to you to play around with it. Yeah, I think this is good. So what I'll do is I think I'll stop talking now. I'll stay on the line for the next like 10, 15 minutes if we want to talk, but you can just continue to work through these exercises on your own, the previous ones or the next one, and just keep on going through it. And on Monday, I'm just trying to think of what we'll do. I guess we'll continue on with these sections. But so how about I just leave it here for you just to do a few minutes on doing some of these exercises. If you're feeling keen and ambitious, keep on plowing through. Otherwise, I'll just talk about these remaining ones. And I said, the goal here is to do these sections and then talk about objects. And then we'll end this introduction to Python stuff, and we'll move on to some other content. But I think that's tons for today. So I will stop the recording here, but if there's any questions, people want to talk to me about things, I am around. If you have some energy, try and work on some of those exercises. And if you're like, I'm done, I can't sit in front of a computer anymore, go for a walk and come back and do it later. That's it.